Hi. So today we will be looking into the second part of embedded interview questions. So before that, there is a comment from one of the viewer. So I think she is asking about why the size was got reduced to 4 byte, not 8 byte, in the last question which I have solved. So the last question was related to the bit fields. So let's jump into it, and I will explain why it happened. Okay. So let me quickly open it. So I have already done some code. So let me just remove it quickly. So first let's write the normal logic. So if I give int a and int b, so what do you think? How much is the size of this structure? So let's run the code. So you see it's 8 bytes, right? So that means uh, 4 byte for this one and 4 byte for this one, so total is 8 byte. Okay, so now what happens whenever I give a bit field of size 1 byte? This one means one bit of, this means one bit, and this also means one bit. So total is 1 bit, but if you run it, you still get 4 bytes, right? Now what I do, I will just quickly copy and paste. So now you see we have in total 8 bits used. But if I still run it, it will say 4 bytes. But normally it should use 1 byte for the entire data, right? What is happening here is that whenever I am declaring with an integer, it is taking the least specific memory required to declare an integer. So for an integer, it's 8 byte. Now let's change it to uint 8, which takes only 1 byte of space. Okay, so let me just quickly change everything to 1 bit uint 8, and with the same I will write one more function, one more structure, data 2. Let me just remove everything. Now just copy. So now see, okay, let me just give us. So now see what happens. Now for uint 8, this will take 1 byte, and we have total 8 bit. So 8 bit makes up 1 byte. That's why the entire data takes only 1 byte. Now you see here, this has actually uint 8 and without any bit fields. So it takes 2 bytes of data because this individual is taking 1 byte. Right? Similarly, what if I make it a 16? So it will take 2 bytes, right? So if I make it 16, now you run it and check. So it takes 4 bytes, 2 bytes here and 2 bytes in the down. Similarly, if I make this as a bit field, now what you think how much it will take? Let's run it. See, it takes 2 bytes because 16 bit itself takes 2 bytes, right? So even if I remove this and remove this, without this also it takes 2 bytes, and using this it still takes 2 bytes. That means the least means the least space required, the least amount of space required for this is taken here. Okay, so I hope this is clear to you. So let's move on to the next question. So let me just remove it. So let's do the next question. Do a number swap without using any extra variables. So this is our question. So what is expected out here is we need to do a swap. Let's say we have a equals to 10 and b equals to 15, but we need to do the swap without using an extra c variable. We cannot use this. So how to do it? Simple. We need to do a plus b, that is in total is 25. Then we need to put, after swap, a should be 15 and b should be equals to 10. So what we need to do, we need to add this and then we need to store it in a. So a is now equals to 25. Now b should be equals to, sorry, now a is already 25. Now we need to put the value of a in b. So what we can do is we can write a, sorry, b equals to a minus b. So how much is a? 25. How much is b? 15. So how much it will be? 10. So finally b becomes 10, and then a we need to remove. So b is already 10. Now we can write a minus b again. So a is 25, b is 10, so it will be 15. Now this solves without the requirement of a variable c. Now let's move to the code and solve it in that way. So this is an interesting interview questions where interviewer expect you to also be able to think out of the box and solve it without using an extra variable. Because in embedded, it is very vital to use the space as consciously as possible. Okay, so let's just write. It's a very easy thing. So let me just remove it. So we say int a equals to 10, comma b equals to 15. So we say printf before swap a equals to percentage d and equals to percentage d a comma b. Okay, and after swap a equals to percentage d and b equals to percentage d a comma slash n. Okay, so in between we have to write the logic. Simple. So a equals to a plus b. So a is shorted. Now we write b equals to a minus b and a equals to a minus b. Okay, I hope this is clear what I am doing. So now let's run it and see the results. So before swap, a is 10, b is 15, and after swap, a is 15 and b is 10. So it's done, right? So we are not using any extra variable, any extra memory we are not using. We are just using an algorithm approach to solve this. Okay, so this is very important. Just remember this. Now let's move on to the next question. Use of static variable in C. So as you know that there are classes in C, right? Storage classes in C. So one of them is static. So what is the use of static variable in C? Why it is so required to use a static variable in C? And you need to demonstrate it to understand it. So let me just write a code and show you what static variable does, so you it will be easy for you to understand. Okay, so first thing, let me write a function. Let's say void print data. Okay, so just let me write print printf, and we say something like okay, int it. So it is always printing an integer. So data is 2 percentage p. And and it also, we also wants to know how many times this is called. So let's say int count equals to 0, count. And now let me just call this function here. Okay. So what happened? Data is 1, count is 1. Data is 2, count is 1. So you see, every time I am calling this function, the count is always initialized with the value 0, right? Now let's make it a static and see the change. See, now the as much as I want, I will just put here. Now run it. So every time 1, 2, 3, 4, 5, the count how many times we are calling the function, it is storing. Now why it is not getting initialized? So that's the behavior happens to this variable count when you put a static keyword in front of it. So what does static symbolizes? So let's understand it. Okay, let's see what happens in the memory side. So if I say static, so it tells the compiler to allocate some memory to variable. So if there is a static int a equals to 0, that means a is already pointed to some space, let's say 080000 something, that is there in the ro data. So you should be aware that in the flash region. Okay, let me just put it in the flash region. We have many types of things, like we have a region where you have the code sitting, we call it dot text data. Then we have some part assigned for constants. Okay, then we have ro data. So this ro data will consist of variable that have initial values, then static keywords in it. So these all will be stored in the flash. And you know that whenever we write something to the flash, it is always available, right? So every time you initialize a variable as static, it is in this ro data, and from ro data it will be copied to the ram section of the memory during processing, and the value will be updated. So it doesn't matter, every time if you call, it will be initialized. Now one more thing is for the static, that goes for the functions also. So let me just quickly show you that also. So let's see, we create another file. Let's say uh, functions functions.c. Okay. So here we like static wa- sum int a comma int b. Let's say just we return int we return a plus b. Fine. So we are writing a static function where we are returning a plus b. Now we just copy this. We write functions h file. Here we do a declaration of this and we say hash include functions h. And we also copy this also here, and let me just remove all this and say okay, let me just keep it here, and that print we call int sum equals to have this sum function 1 plus comma 2, and we pass sum. So what we did, we wrote a function in the .c file, we included it in here, and we are calling it in the main.c. So let's run it. It's easy, right? Failed. Okay, what happens? Okay, fine. Semicolon missing. Still, it is saying warning. Sum was never used. Okay, what is why it is not used? Now, what we do, we create another function. Now, instead of static, we remove it. We just put someone, and same with the declaration. Here we give this. Here we put someone. Right. Now it is working, right? So if I make it sum, why it is not working? It's not working, right? Now again I go here. In the sum function, sum one function, I will call here sum function. I will call here sum function, and in this I will pass a comma b. So what I am doing in sum one, I am calling sum, and here I am running it. So what it is calling? Okay, expected that. Sorry, I'm running it. Okay, so still it is not working, right? So it is saying the static int sum, this one, and here the sum is not defined. So what we do, weekly remove it, come here and define it, run it. Undefined reference to sum. Okay, it should be static inline. Okay, so let's see what's the importance of static in the functions. So let me just create a new file, say functions.c, and one functions dot h, a header file. Okay, now what I will do, I will create one function. Let's say static void static int sum int a comma int b, and let's return a plus b. Okay, and similarly, let me just first create this function like this. Okay, and take just make a header file of it. Okay, so definition is done here, it is done. Now let me just include here, sorry, include functions dot h file. Okay, the same I will include in the main file, and here what I will do, I will just print printf sum is equals to percentage d, and we call the sum function 1 comma 2, and let's see what happens. So the sum is 3. Okay, so now it's simple, right? Now let's put a static keyword here. Simple, nothing changed, only put a static. Now we go to the definition and put a static here also, right? No changes. Now if I run it, see, lots of error. So it's saying undefined reference to sum and all, so we are not getting it, right? Now go here, I copy this function, write the same function, remove the static from here, name it sum1. Okay, copy the same declaration, go here, put it here, go to main, and instead of sum I put sum1. So and run it, nothing changed, so it is working fine. Only due to the static keyword it's not working. Now let's do some modification here. Let's call this sum function here. Let me just say sum, instead of a plus b we pass a comma b here, and return it. So in main if I run, so we get sum is 3. So what we are doing, we are calling the sum here, and we are returning whatever value we are passed here. So now what's happening, why we are not able to call the sum function in the main but we are able to call it in the same file? So that's what the static keyword will do. It's act as an access modifier in C. Okay, so once you have put a static keyword in front of that function, this function can only be called within that same sheet or within that same code part. You cannot call it. Now what's the benefit of it? You can restrict the functionality to that sheet. And also what we can do is, I can define another function like here. Let's say I write, oh, let me just copy it from here. Control C, Control V, and remove it. So I have another function definition here, and let me just write a function, same function here also. Return A plus B. Okay. And instead of sum1, I call sum. Let's see what happens. So it returns the same thing, right? Now look what happened if I put here sum1, here also sum1, and here also sum1. So what it is going in the function sum, multiple definition of sum1, because sum1 is defined here also and sum1 is defined here also, which is already included here. With the use of the static keyword, you can define multiple functions with the same name, and with that function with a static keyword, it cannot be called in another sheet. You also use it as an access modifier. Okay, so let's now move to the next question. Okay, so let's move to the next question. What is a static inline function in C and difference between inline function and macro? So it is very important question. So to understand it, let's first see how the compiler works at the background. Okay, so let me first give you a understanding of how macro and how an inline function works here. So let me open the compiler. So this is compiler explorer. You can use it to see how the output codes is there when you write a source code. So let me just write it quickly. So if I say function as let's say void func1, and here I say printf I am func1. That's it. Okay, so this is one function. I will copy the same. Let me just say it instead of int. I will say okay, fine. Let it be int, and let me just say it. Number two. I am function number two. So two functions are created, and here I will write static inline functions. So what is happening? So the static inline function definition you cannot see, right? Only function one definition you are seeing. Now, when I write void call func, and in this call I will say func2, now you can see in the call function 2, in the call function 2 is defined, then the call function is there. So if I remove it, now you see there is no existence of function 2. Okay, so what is happening? So whenever you write a static inline function in C, it will not create an overhead in the stack. Like when I call, if I say call function 1, okay, it's simple. In this you are calling function 1, it will go and call the function 1, and so what's happening here is, okay, let's understand what's happening. So you have a static inline function, you have a normal, let's say you give it function 1, you have a normal function 2, and you are calling the function in like function 1 and function 2. So after compilation, right, what is happening is, let's say in the static inline function you have written a plus b. Okay, now when it is compiled, then it looks something like this: a plus b, and then a function called to c. So actually this function will not be calling the function, instead this will be in the compilation time will be replaced by the contents of the function 1. So what help it is happening in our code? So when you do a call to this function 1, so when you call this function 1, so this will go and only create, like you call to this func, so this will create an overhead of func2. So ultimately this is the stack, calling stack. So it will create a pointer for function 2 and also function 1, but it will never create a pointer for function 1, because function 1 will be replaced by its content inside the func. So now what happened in case of a macro? So let's write a macro here. Say macro. So we write a macro hash define, say func b, a comma b. You can write a function a comma b where we will pass hmm, it will return the value a plus b. So here we write int c equals to, it will give a return of a plus b. So you see in the function call there is a return of 3 here. Okay, so if I make it, let's say 4, okay, so there is a return of 5. So in the runtime what is happening, this will be replaced as a text format. So instead of this, if I write, look at this code here, So instead of this, if I write 1 plus 4 and then I comment it out, the whole thing remains same. So what's happened, whenever you are calling a macro, it's just a text replacement, nothing else. Okay, so inline function is not a text replacement. This will only be replaced when there is a call to the function, whereas the macro is always replaced irrespective of whether this function is getting called or not. So ultimately the conclusion is, so it is that macro is text replacement and inline function compile is runtime replacement. So this is a text replacement. So this happen irrespective every time. This happens when call happens. Okay. So this is the difference. Now let's look into another question. So let's look at the next question. Write a code to demonstrate function pointers. So what is a function pointer? First, we need to understand. So when we write a function, let's say we write a function. Let me just let's say we write a function void func1 and we give something like print f, something we print. Okay, so what happens during compilation time, this func1 will be saved at some location in the flash. Now the memory is allocated to the function and the variable which points to the memory is a function pointer. Why? Because it is pointing to this memory which in turn stores the function, so it is called a function pointer. I hope it understand. So ultimately the thing is, any variable that contains the address of a function is a function pointer. So let's understand with the code. Now let's see, let's write a function. Let's use this one only. Okay, so what here, there is a function that is someone, and let me just get rid of these, delete. Okay, so we have one function someone, and we have, and it just does sum of two variables and return the result. Okay, so simply if we run, so it is okay, okay, fine. So it is working fine. Now, if I want to call this function via function pointers, so first thing we need to see what is the return type of the function. So it is an integer. So we write the integer return type. Then we say it's a function pointer, simple. And then what is the arguments? What are the argument type? Only write the type. It is int and this is an int. So fp is a function pointer which has a return type of integer and which takes two integer as an argument. Done. Now we say fp points to someone. So we assign it someone. So here someone is, we can say someone is the function's pointer we are assigning to fp. Now instead of this we can call this one fp and see the result. So it is still working, right? So what we are doing, this is function pointer declaration. So how it is defined, first is return type of function. Okay, then star function pointer name, then argument type. Okay, so this is how we define a function pointer. Then assign the allocated address. Okay, so you understood it, right? Now let's see, we have another function. Let's say it says is nothing but, let's say it prints void print in pay. Okay, there is no return type, it just prints. So we can write printf and says percent d comma a. So it prints whatever you pass. Now fp is having the function pointer of sum, so we declare another which is of void type and star fp1, and it takes a value of int. So now we say fp1 equals to print. Okay, so instead of this we can just say fp1 and have fp with value 1 comma 5. So now it should print 6. So if I do this, it prints 6, right? So this is how the function pointers actually works. So function pointer will always take the address of the function, and then it we can call the function pointer with the value we required it to pass. We go one step ahead. Okay, so let me just say it is in some, maybe we have here multiplication, so it will multiply. Now in, instead of some one, just say null and rerun it. So it will give you 5, because 1 into 5 is 1 into 5 is 5. So that's how it works. So it it doesn't matter the name, it only checks what is the argument, and what is the return type. Like this you can define it. Okay, even you can define the function pointers array like this. Now let's say fp0 is, say sp1 is this. Sorry, not here, maybe someone. Okay, so here we have to give fp0. So see, fp0 is sum, so it is doing the sum. If we pass fp1, then it will do the multiplication. So like this is the format of declaring the array of a function pointer. So this fp is an array of function pointer, so we can give multiple function to this inside this array and store, which has the argument of type integers and which has a return type of int. So this is how we can also create a function pointer array. Okay, so I hope you understand. So let's move to the last one. So this is find the maximum of three number without using an if else statement. So what it is asking, it is saying, let's say you have three variables. um, you have three variables: a equals to 5, b equals to 6, c equals to 10. You need to find which one is the greatest, but you cannot use if a is greater than b like this statements. If else you cannot use. Okay, how to write a function? This is also a very good question. So for that, let's jump quickly here. We remove this. So how to write? So we solve it using macros. Okay, so now let's write the code for macro. So you write max x comma y comma z. So these three will be the variables that will be evaluated. So we write an if else in form of a statement. Okay, so how to write in form of a statement? So it's easy, just we say if x is greater than y and x is greater than z, that means x is greater than both. So if this is evaluated, then return x. Else if y is greater than x, ampersand, y is greater than z, return y, else return z. Simple. Let's try it. So we say we have int a equals to 4, comma b equals to 1, comma c equals to 10. Okay, so we write printf max is percentage d, that is max a comma b comma c. Let's see what is the output. So max is 10. Similarly, if we make it 14, so it should give 14 as max 14. So this is how you write find the maximum of the three variables without using any if else, and without if else, and using a statement. Similarly, you can write it for mean also. I think this you can try yourself to find the mean of the number. Okay, so hope this is clear. So I will come up with more questions in the next video. Thank you.